So without further ado, we will introduce our first speaker. So first up, we have Dr. Margaret Fournet from the Athlone Institute of Technology. And before we get started, we're just popping a little poll there into the, you'll see a little poll tab there that should be popped up into the chat. And you can take a vote on any one of those things that you think are best. And this is somewhat related to Margaret's talk. And hopefully you'll have a clearer understanding of what that all is about and what the best solution is at the end of the talk. Great. So Margaret, please do go ahead.
Hello, everyone. I'm just going to share my screen here.
Great.
Okay, that's popping up there. And the poll is still up, so I can't see.
Yeah, we can see that. Don't worry. Oh, I will take the poll down.
Great. So my background scene there is a vineyard. I have a license to do that since my second name is Fournet. I'm sure we're all aspiring to getting to there, maybe even this year, but definitely by next year. I'm going to talk about plastics, and the first thing you see there are glasses of wine. We all like to have glass for our wines, and there's wine there for everybody's taste, different colors to suit all different tastes and all different requirements. To get straight into it then, why do we use so much plastic when you can things like glass? I think that, you know, is a question that answers itself. We're quite addicted to plastic. So even though we like glass for our wine, we may take picnic glasses, plastic picnic glasses for wine if we're going for a picnic because, well, they're light and they're not going to break on us. But overall, we need to consider what's going on with these plastics. But I'm here not to tell you a story of horrors and more terrible figures that are going on. It's a story of hope, because we can solve these problems and we do have the means to do this. So if I show you a different picture instead to get us started, imagine the situation here where you have a punnet of strawberries and you go to buy it in the supermarket. And then the next time you go back to buy your punnet, that this punnet actually contains plastic molecules from the last one. So that we didn't have to pull out any more oil out of the ground to make this new punnet of strawberries. So this is the picture that we want to get to be able to have full circularity with our plastics. Just having a little bit of a problem there on my screen. Oh, there, it has changed. But as you know, we're all quite addicted to plastics. Plastic is actually fantastic as well. Plastics make lots of things possible. You can't even get as far as brushing your teeth in the morning without meeting plastic in your toothbrush. You may even have plastic fibers or plastic polyesters in your pajamas. We use it for everything from sunglasses to protecting our fruit and our cucumbers to our Xbox or PlayStation console. If you want to go into space, as Quiva might be talking about later on, you'll need plastic for that spacesuit. And this guy here, he's wearing the lightest soccer boots in the world, all because of plastic. And his ball has exceptional cushioning and he can do great movement and skills with it because the features that plastic allow. Our cars, they're all sleek inside, they're extra safe because of plastic features. And they only take up 10% of the weight, yet it occupies 50% of the volume of our cars. We've been working on this for over 50 years, and that's why plastics are so great. But we forgot one important part: what to do with them when we were finished using them. So if we can consider then, plastic is a half-finished product. And that's what we need to work on. And that's what we can work on. I'm not going to show, as I said, show many scary statistics, but I just like this one, which has a bit of hope in it because it shows Earth Overshoot Day. I'm still struggling with my screen here to move the thing. I can't see the quote exactly, but you can read it there. It says something like, no, we're not going to stop using all these things to make the world better. And then nature says, here's a virus, practice. And it showed us that last year, Earth Overshoot Day moved back by about 3 weeks because we did less. That's because of COVID, because we were all locked down. We couldn't use as much carbon and use as many substances and produce. But it gives us hope that we can actually do this. I want to paint a picture of this. If you go back to the way the world began, Caoimhe knows a lot more about this than I do. But it was a pretty fiery place. It was like one big volcano. And there was a lot of carbon around. Carbon dioxide in the atmosphere was up to 9,000 parts per million. Then life started getting into action, and it sunk all that carbon. All these plants and life forms sunk all that carbon into the bottom of our seed beds and into our bogs. And so the pre-industrial movement, we had about 220 parts per million of carbon. Whereas now with our activities today, we're at 420. So humans, in our ingenuity and everything, we thought was a great idea to start like digging it all back up again to use for our purposes, flying around the place, etc., using the oil to make lots of plastics. Sorry, if there's Anya, is there any way I can move the screen? Oh, I have it now, sorry.
Okay. I think there's just a slight lag in it, but it is moving on.
Yeah. Okay, so I just want to think a little bit more. If you take another step back, here's a picture, and I'm not an anthropologist, and I won't be able to pronounce the names of these, so I won't try with too many of them. To look at our story, our human story, it's quite a complicated one. There's no direct line. So you have their Australopithecus. I've heard that one pronounced, so I can pronounce it, all the way up to humans. But if you look at this over on probably your left-hand side, you can see the skulls, and you can see there's quite a complicated chain of them. And we're Homo sapiens up there at the top. As we know, we're the only ones that survived to date. The Neanderthals there just beside us, they died out a little earlier. And then there are other species like the Denisovians. And when they've looked at the recent work on this, they found out that we used to think that, it was an insult to call somebody a Neanderthal. Maybe they weren't very clever. That's actually, they've showed that these pre-human species actually were very intelligent. Indeed, some of them may have been more intelligent. Some of them have a bigger brain size than us. Now, there's a lot going on there. We used to call people bird brain as an insult as well, but now it turns out that birds' neuronal density is multiples of that of mammalians, so they actually have a really high intelligence. If you put humans, like if you take an 8-year-old child, they've done tests versus a crow, the crow will figure it out faster than the child, and the crow's not 8. So the question is then, why do humans win out? Well, the one thing that we are really good at, over all species that we've tested so far, is that we're good at sharing information. So when the Neanderthal man made a great new tool, he used it away, but he didn't tell his neighbors or his friends or the next group. But humans did. And we built upon that. And we're great at sharing information. And that's really why we are so advanced today. And that's why the crows don't rule the world. One proof of that is the white of our eye. We use eye contact to communicate. Another reason why it's kind of hard to do this virtual stuff, because we don't know where the white of our eyes are actually directed at the moment, somewhere on the screen, but you can't tell if somebody is really looking at you. But we are very good at sharing information, and that's how we've built ourselves to be where we are at this stage. So we are still very clever. We figured out all these cycles. Here's the nutrient cycle. There's the citric acid cycle that happens inside your body, the carbon cycle. And down at the bottom, I can't really read it at the moment, but even the universe itself operates within cycles. A Big Bang is predicted by these two Princeton professors to occur every trillion years ago or so, starting the whole process again. So nature operates in cycles. We know intricately the details of those cycles, but we still kind of have been continuing in a linear mode. And it's not like we haven't the lessons from history. This is probably taught in many schools across the country and abroad and elsewhere. The idea that of what happened to the Mayan civilization, their linearity. They used too many of the trees in the forest to create this lovely limestone and smooth veneer cladding on their buildings for their elite people. And well, it went a bit too far, and there wasn't enough left, and there was famine, and that was the end of the civilization. However, for humans, we're beginning to realize this, hopefully in time. Yes, in time, I do believe. And we can, with science and how clever we are, use science collectively to solve these problems. An example of this is a project that I lead. It's a Horizon 2020 project. You may have heard about it. It's called Bioinnovation of a Circular Economy for Plastics. So this is one of those Horizon 2020 projects that are directed around these now. There are multiples coming out, and we're beginning to cluster together to work collaboratively and together to solve these problems. So to tell you a little bit about our particular one, this project spans Europe from the west there, Ireland and Portugal, all the way over to Serbia and Greece. And then we have Chinese partners as well. So it's a global effort, if you like. And we've got a twin project as well that are doing the same, and other projects. So there's lots going on. But our particular approach, and I don't want to get too much into the science of it, is we're going to funnel those mixed waste plastics, and we're going to regenerate them as better plastics, as plastics that can have the properties that we want, but without the harmful polluting aspects to it. And we do this by going back to nature and looking at how nature does things. Nature's full of polymers. Polymers are not new. DNA is a polymer, glucose, they're all polymers. Sugars are polymers. And nature deals with these all the time, and it doesn't let big stockpiles or pollutants build up. It goes through a process that we're all familiar with. Things get weathered. Arthropods, that's your worms, they chew things up. If something dies, they chew it up. They start that, and then the microbes come in, and they break it down. And then you get a set of building blocks that can be repurposed, either maybe within your body, or for example, to push up the daisies, the grass comes up and the cows eat the grass, and the story goes on. So I've used this green barrel up there in the right corner, mimicking this. Now we need to be a bit more harsh because our polymers that we've been so good at making over the past 50 years are quite, inert. They're bio-inert, they're pretty rigid, they're pretty unreactive. So we need to have a few strong approaches to follow all these paths. But on the first one, the Meccano one, we have scientific methods that have already been developed for plastics and other things, and we are applying all of these to loosen these plastics up and make them less bio-inert, to break them apart a little bit, damage some of those chains, and let those ready for those microbes and enzymes to actually carry out their work and break them back down into their simpler molecules. So back to step 2 then is the enzymatic part. Now this looks all very complicated, and it is. We're not going to say it isn't, but basically with our pre-treatments, we have broken those chains of polymers down a bit. We're able to find microbes that can actually put them in through their metabolism and come out with more finer breakdown, or maybe even a new biopolymer at the other end. Here's stacks of some of the materials. Some of the students that may be watching are responsible for some of these, or some of our other partners. So these are actually stacks of plastics with microbes growing on them. And I've listed some of them there. PET you might know of, polypropylene you might have heard of. And we're looking at the growth upon those.